Thank you. So, hello, my name is Jiří. I'm from SUSE. I have the experience for past 2 years of working on upgrading OpenStack, and that's what I'm gonna talk about. So, yeah, maybe just a first explanation. What I want to talk is I want to share some experience we did in our team with upgrading our OpenStack solution. So I'm not telling you how you should upgrade. I would like to just show some examples of what we met. Basically, I will start with some upgrade introduction, short talk about what non-disruptive upgrade could mean, basic presentation of how our SUSE cloud upgrade looks like, and then I would like to delve into some interesting technical cases. If there is a time, I could show some live demo, but yeah, we'll see. So why do we want to upgrade? Basically, you want new features, and you want to fix the old bugs, because well, new releases are coming bug-free, right? So the problem with that is OpenStack release cycle. As you know, OpenStack releases every half a year, and well, I can't speak for everyone, but I believe not every OpenStack distribution delivers every OpenStack release. And I would also believe that not every users want to upgrade every half a year. So, for example, we are offering every second major OpenStack release in our SUSE distribution. So the problem is how to do that actually, how to skip a release during the upgrade when it is not officially supported, or at least it wasn't officially supported at the time we started developing this. And the next good question is how to upgrade and not to limit your cloud users, right? I mean, everyone can upgrade the way that you just shut everything down and upgrade the packages and start it again. But that's not what we want. But there might be some perfect solutions, but we think we actually have to limit users somehow during the upgrade, but we try to not to do it that much. The buzzword here is non-disruptive upgrade. The question is, what does it really mean? When we first got the assignment to build this non-disruptive upgrade, we asked, what is it actually what users care about, what is really beneficial for them, and what is actually technically possible with our platform. I'll talk about it later, about those technical possibilities. And we came up with the definition that for us, the non-disruptive upgrade is the upgrade for which existing workloads are functional during the whole process. That means the compute instances are running, they are reachable by network. But there are some limits during that. Users cannot start new ones, cannot stop or delete existing ones. That's because some or all of OpenStack services may be down during the upgrade. We try to minimize the time, but we actually haven't found a way around that. So that's not part of our definition of being non-disruptive. And the last point is about the fact that maybe not every operator actually needs that. So we should not really force them to do the non-disruptive version of the upgrade, and we should allow them also to upgrade some maybe faster way. Yeah, faster actually. But in most cases, I will be talking about this non-disruptive version. So what is it I'm talking about? SUSE OpenStack Cloud is OpenStack distribution. It's deployed traditionally on virtual or real hardware, so no containerized solution, no fancy container management tools that might help us for the upgrade as well. We have to deal with that. We are using Crowbar as a deployment and management tool. That's the currently is open source project. It was started by Dell some years ago, but I believe we are the only ones using it. It's a Ruby on Rails application that is offering obviously some REST API and some web UI, and that is running Chef as a way to doing the actual configuration. This Crowbar is running on so-called admin server. So admin server is kind of an extra node to your cloud infrastructure. What we have to know as well is that everything runs on Linux, specifically SUSE Linux Enterprise Server, and our cloud release has specific version of this product of SLE, SUSE Linux Enterprise. So that means that once we upgrade, we cannot just upgrade the services. We need to upgrade everything. We need to upgrade the operating system. We need to upgrade all the system libraries. We need to reboot each node, including the admin node. And yeah, we have to solve it together. So just a summary. I have experience with doing upgrade from SOC. That is for SUSE OpenStack Cloud, from SOC 6 to SOC 7 and from SOC 7 to SOC 8. And SOC 6 is running OpenStack Liberty, and it is running on SLE12 SP1. SOC 7 OpenStack Neutron, SLE12 SP2, SOC 8 is running Pike and is using SP3. As you can see, there's always one OpenStack release missing. So what's the basic concept? Of course, it was said in previous session if you were here. First point is the setup needs to be highly available. So all the nodes in the control plane are forming pacemaker clusters where the services are running either as in active setup or active passive. That is, they are running on all controller nodes. So once one node is down, there are still other nodes that are providing the services. So when we have this setup, we can think that, okay, it should be actually easy to just take one controller of the cluster, upgrade it, and other nodes from the cluster are still providing the services during that time. Then we just take another node, upgrade it, and so on. So that sounds easy, right? For the compute part, the obvious solution is here the Nova Live migration. So running instances could be moved from one compute node to another. So yeah, we take one compute node, live migrate everything from that one, disable the compute service on that node so it is not used during the upgrade. Then upgrade packages, reboot the node, as I said, it's necessary, reconfigure to new upgraded services, and start them again. Voila, compute node is ready, and we can proceed with next one. That actually sounds simple, and why shouldn't it work, right? So just some basic schema in a picture. You can see we have some. This is a simplified version, obviously. We have some controller cluster with 3 controller nodes providing the API, compute nodes, each hosting some VMs. And yeah, you can see there are, for example, no storage nodes here, but should be enough for our case. So when the first controller is being upgraded, the old version of the API, let's say version N, is provided by the rest of the cluster. And once the controller is fully upgraded and functional, we shut down services on the rest of the controller nodes and start providing the new version of API, that is N+2. Now that was a high-level view, and let's look into some details. So how does it look with compute? Nova. We can see that now we have. Let's assume the control plane is fully upgraded, right? Like as we've seen here, like continue with first, second, and third controller. Everything is upgraded to new OpenStack release. Compute nodes are still running the old version, that is version N compared to N+2. And what does it mean for those instances? They should be still running, right? We did not do anything to compute nodes. It should be still reachable, but we'll talk about it later. And now we need to do this live migration step. For that, we need the Nova on control plane to communicate with Nova compute services and compute nodes, which is not automatic, right? As I said before, N to N+2 upgrade is not officially supported. So if it works, we just got lucky. It works when going from 9 Newton to Pike. Yeah, so Nova controller running Pike can work with Nova compute running Newton, and we can do live migrations. And there's one exception that will be on the next slide. For Liberty, for move from Liberty to Newton, it was not so easy. I mean, Nova I do not exactly remember what caused that, but it definitely didn't work. So what we did was, after we upgraded the control plane, we just went to compute nodes and upgraded only Nova compute packages on there, so that there will be same version of Nova on all the cloud nodes, and they would communicate correctly. And you can say this is kind of ugly solution. Those compute nodes are in somewhat undefined state. They are running still the old version of operating system, but the Python packages with Nova are upgraded. And it is true. I mean, we just hope it's gonna work. It will work, and it works. For the time of the upgrade, it seems to be good enough solution. Fortunately, as I said, with next version, it worked better. So the one exception I said is a little bit problematic is Nova placement. This is a new service. In Nova, as far as I know, takes care of resource allocation that was introduced in Newton but made mandatory, I believe, in Okata. And as we are skipping the releases, we do not have any Okata, right? So when we are upgrading from Newton to Pike and there is no Nova placement configuration, Nova, I do not remember the exact errors out there, but it basically stopped working when we tried to live migrate, because it complained that the Nova placement is not configured, at least. So fortunately, it was already the support for placement was already included in Newton code base, but it was not really perfect. So we basically had to backport some Pike patches to Newton, and we had to release maintenance update. So our SOC 7 users, that is our users using this Newton-based cloud, could have the right Nova configuration that is including the placement as well. Once we have this set up, it works. So basically, we had to find out and we had to solve it. We made it, and which reminds me, that's of course the requirement before the upgrade. All the maintenance updates are installed. One of the maintenance update was this Nova placement configuration. So Next problem, there is the network connectivity. As I said before, once the control plane is upgraded, the instances are still running, right? But when we tested it, like some first prototypes, we've seen, okay, we are losing some network connections. It was because we did not realize that some of the control nodes with the Newton services, with the Neutron services, are actually providing the network traffic for the VMs. So when we upgrade such node, stop all the services out there and reboot the node, we just lost the network connection. So what we had to do, we've wrote this simple Neutron HA tool, which is basically a Python script using Neutron API mostly, and we use it for evacuation of existing routers and load balancers from a node before we start upgrading it. So basically, as I said before, we start with upgrading one controller node, and we start with this router evacuation thing. Then we can fully upgrade all the packages, reboot the node, let it come back again, reconfigure new services, and it seems to be working. When we go to the next node, we just have to remember again, there might be some routers. This time, we just do not evacuate them like anywhere available, anywhere possible. We just move them to the new node, so to the one that was already upgraded. So we do not have to solve this situation again. And yeah, basically we realized that, as I said before, we need to stop the API at some point. But obviously for these actions, we need Neutron API to be running. That means also Keystone and message queue, RabbitMQ in our case. So again, we just realized we need to wait with stopping the services at least until this network setup is correctly solved. Okay, database schema. So every OpenStack component has its own database, which has its own schema, and every component comes with those manage commands. Like one of the command for those manage tools is dbsync, which basically upgrades the database schema and upgrades the affected database entries whenever some changes added to the code, that changes the database schema, new migration is added to the code, and those migrations are executed in this with this dbsync call. So usually we run the dbsync after the package upgrade. Yeah? So we upgrade the package to new version and run the dbsync to migrate the database to the new schemas. That works fine most of the time until we meet this online data migration thing that was introduced in Nova, I believe, and later in Cinder. So for example, let's take Cinder for example. They came up with online data migration in Okata, and those are the kind of migration that should take care about the data changes. And the interesting part is, and what is officially said in Cinder upgrade documentation, is that such online migration should be run from Okata. But again, we do not have Okata, we have only Newton and then we have Pike. Can we somehow skip it? We cannot really skip it because the dbsync that is necessary makes sure that the online migrations were executed before, right? So for some time we considered like installing Okata packages for a short time. That I believe is the official OpenStack position that should be done. But we came up with sufficiently simple replacement actually. So we took the one migration that was actually introduced in Cinder as online data migration and took it as a patch and move it to our Pike packages. And then we just do Cinder manage dbsync up to certain revision. That is the last revision that was required before that online migration. Then we run this online data migration command, but that was also already after the upgrade. So we already have installed the Pike code. So our patch is in there. So the online migration, the right online migration is executed, but with the Pike code. And then we run the dbsync again to sync to the latest version of the database. So it's actually pretty simple, fortunately. Yeah, but that was actually the same case as was happening with Nova when we were upgrading from Liberty to Newton. I do not remember what was the change back then, but yeah, that was the same case and was solved the same way. Basically, moved the online migration to the next release in our own packages. So this is not about a bug, but about actually a feature we've introduced when doing this SOC 7 to SOC 8 upgrade, that is Newton to Pike. So, as we've seen, everything should be solved, that once the control plane is fully upgraded, then the API is actually already running, right? And as we've seen before, Nova is also communicating correctly between Pike and Newton. So we basically have working cloud back again. It is not fully upgraded. The compute nodes are still running old operating system and old version of OpenStack. But as long as we make sure there are no other services, no other OpenStack services on those compute nodes, we can say to users, okay, you can now postpone the upgrade of rest of the nodes until some later time. And basically let your users already use the cloud because it is usable. So what was the problem with that? As I said, the collocation of services. For example, you cannot put your Cinder volume services on those compute nodes because, as I said, there is nothing upgraded on the compute nodes. Cinder actually requires that all of the services are running the same version. So that would not work. But yeah, so we basically made this as a kind of a requirement that we check for before the upgrade starts. And yeah, so once we are at this stage, we can say, okay, the upgrade of the rest is postponed, and you can even go run your crowbar and modify your OpenStack configuration as long as it is affecting only the control plane. And you can upgrade the compute nodes at some later time. You can even do it one node at a time in a way you feel fit. So, okay, that's just few words about, that's what I just said. Just we have to think about what should be the supported scenarios. As I said before, obviously one of the necessity is the HA setup. So we do, before we start the upgrade, we do some kind of checks that say users, okay, your setup is not ready for the upgrade. It is not highly available, or it has Cinder volume services on compute nodes, or Nova is not configured to allow live migrations. Actually, no idea why would anyone configure Nova that way, but it's possible. And there are some funny cases. Like, as I said, there is this admin server where the crowbar actually runs. And I believe no users are actually doing that. But developers are lazy. And they tend to use their setups for stuff that they should not. So for example, we were kind of used to use this admin server, for example, as a NFS server for Cinder backend. Or even worse, we use it as shared storage for SBD for the stonic mechanism for HA. Well, that's funny, right? Because as I said, every node needs to be upgraded. Admin node is upgraded as well. It is actually upgraded before all the nodes. And when it is upgraded and rebooted, you lose the shared storage for SBD. Your pacemaker clusters start to burn in flames, right? So that was just a note for what cannot be, should not be done at all. So this was about interesting cases about during the upgrade. Now I wanted to say a few words about one issue we've came up with this latest upgrade when we are doing from SOC 7 to SOC 8, because the fun part of that is the database change. We decided it is time to change the default database engine. With Cloud 7, we've usually offered Postgres. It was decided that with Cloud 8, the default should be MariaDB. And that is not as simple as just installing MariaDB as a new packages and configuring if we need to migrate all the data as well. So we have to ask several questions, like when we should do such migration, should we kind of tie it to the upgrade, or do it before or after? What we basically we decided to do the migration before the upgrade starts, mostly because so the users could actually schedule some time for doing the data migration, or complete database switch, including data migration at some point, and then maybe at some later point doing the upgrade. Another question was, where should we deploy this new MariaDB? Should we ask users to bring new nodes, new hardware before the upgrade, 3 extra nodes for hosting a Galera cluster? Not everyone would be happy with that, so we had to find a way to enable deploying MariaDB to the same nodes where Postgres is running. There's one interesting case with that, because with SOC 7, with Cloud 7, the Newton-based one, but okay, that's not important right now. We allowed clusters of 2 nodes for Postgres databases that would be backed by DRBD. But MariaDB HA solution Galera needs at least 3 nodes. So we had to figure out how to actually add a new node to existing DRBD cluster so that it forms pacemaker cluster, but all those DRBD-backed services, that is Postgres and potentially RabbitMQ, are running only on the old nodes. That finally we make it work. We had to use some pacemaker magic for that. And we had to allow users to deploy MariaDB that is correctly installed and correctly configured for running, but not yet configured for the OpenStack usage. So basically in short, the process goes this way. Users with SOC 7 can deploy MariaDB into their existing setup. They use those existing OpenStack management tools to create a schema in the target database, in the MariaDB database. As I told, those manage dbsync commands basically create the correct tables in the target database. Works nicely. Then there is a need to stop OpenStack services, obviously, because when we want to do the complete data migration, no one can run into database and create new data, right? Then there is time to actually migrate into data, which you have to SQL-based databases. You could think it should be easy, but actually it isn't. There is some incompatibility in the SQL they are both using in some data types and so on. So we had to write our own tool for that. And then we could reconfigure all the OpenStack services to actually use MariaDB, and that's it. So that was in short. If you are interested, there is a special session about this in Berlin Summit, and Rolf and Steve are gonna talk about it. So enjoy if you want to go to Berlin and know more about database migration. And that's it. Then now would be time for a live demo, but I am not sure if we are not out of time.
No, we still have time.
Sorry?
We still have time.
So, do you want some demo? I wasn't really expecting this, but let's see. Everyone knows that people should not do demos, right? So let's try that, right? Okay, VPN is down. So no live demo. I will only say you that this upgrade tool we've developed is actually tied to the crowbar management tool, as I mentioned before. It has the web front end. It has a command line interface, which I found like more interesting. You can use the CLI to check the status of the upgrade, to run specific upgrade steps. As I said, there are different. I did not say that. I kind of implied that. So first, you have to do some preliminary checks that tells you that will tell you that the upgrade is actually possible. Then you will do some specific checks that check if you have correct software repositories, because you are doing the upgrade, right? You need to check that the upgrade, where the upgrade can get the packages. Then you need, then another next step is upgrading that admin server, which is fun, for example, from that web UI point of view. Because as I said, you are running this CLI or the web version from the admin server. So at some point, you just lose the connection when the admin server reboots. But so we basically put something in documentation. Just don't worry if you lose the connection. The server is rebooting. It will be back. And yeah, that's mostly it. Then last command of the upgrade tool is upgrading the cloud nodes. You can actually provide specific options to that. You can say just upgrade the controller nodes, or you can say upgrade all of the nodes, or upgrade one specific compute node that is identified by name or address. And yeah, you can watch the status in some YAML file, and that's it. Some basic links to SUSE Cloud, to Crowbar, and to the Python script that is actually the database migration tool, as I said before, from Postgres to MySQL to MariaDB. And that's it. Any questions? Oh, that's a good question, but not really for this topic. I was really the implementer, the kind of leading the team that was implementing it, but not designing that. So that was, I believe, there was a feeling that the upstream community is moving more to MariaDB, and that we need to switch at some point. We could actually provide Postgres still in our version, but it was decided that if we are able to provide the migrate solution, we should do it as soon as possible. So we did it like with this release. But yeah, this was probably some political decision more than technical one. I'm not sure.
So you're going two version steps of OpenStack versions all the time. Does the upgrade process contain any steps of installing integrated
No. Actually, yeah. We just upgrade from Newton to Pike or from Liberty to Newton directly. The DB sync usually works because it already contains all the migration scripts, and all the cases where it wouldn't work, we had to solve separately, like that Nova not talking with N+2 version when going from Liberty, that we've solved by upgrading only Nova. Yeah, we were thinking about this intermediate release, and we were okay, that could be our backup option, but we would need to provide the extra packages somewhere on the media, and there would be some extra work for us. Might be better for customer, not sure, but when we found out that it's actually possible to avoid that, we just did not do it this way.
What do you do with deprecated configuration options, the config files?
The config files like for OpenStack services. Well, they are left as they are. We have this config directories. It's just not keystone conf, but keystone.d directory where all the configuration is written. So basically, our configuration is written by chef, but if user has any extra specific configuration option that could not be tweaked by crowbar, they could just add extra configuration snippet there. So it is not removed, it is just
Regenerated or?
Sorry? No. It just the upgrade doesn't delete those files. Yeah, so if there were an option that actually works in one version and breaks something in next version, and it was added by user manually, we wouldn't be able to find that out. So that would be a problem. But in general, we keep user modified config options, if that was the question. Yeah.
Okay. I have one more last question that I'm curious about. I really liked your point about not all upgrades needing to be live in the sense of like having the system up. So have you considered having a different, like, I don't know, upgrade path?
As I said, we have these pre-checks for start. When we do run the set of checks and we say, okay, your setup is ready for non-disruptive upgrade. If it is not ready, like there is no HA setup, or there is, I don't know, this collocation problem with Cinder or something else, it says you can still upgrade, but in a normal mode. The normal mode works that it upgrades all the compute nodes in parallel, so it's actually faster because this one is doing one by one. But before it starts doing it, it tells user, oh, there are some running instances there. Go and shut down or suspend them manually, and then you can resume them manually. That's up to you. We only tell users there are some running instances, take care of them, right? And just one more bit about this. Even if the cloud is capable of this non-disruptive upgrade, it is possible to force it to do this normal version. Just change the upgrade mode. That is one option of this upgrade tool we have.
And that will be faster.
That is faster, yeah. But yeah, the instances are down during the upgrade.
Yeah, okay. Okay, so I satisfied my curiosity. Let's thank the speaker, and thank you for joining this track.